And there's the airplane. We're taking off. Now, folks, let me explain how, just a moment here, how X-Plane works and why we can even begin to design airplanes, and never mind fly them and whatnot. It works because they use something called they call it blade theory. It's also called finite element analysis. And what they're doing is they're cutting up the airplane in pieces and then calculating, well, if you're at this airspeed, this angle of attack, this kind of atmosphere, plus some other parameters, what would that piece, how would that piece behave? And then it reassembles all the pieces and tells you what the whole thing would do. And obviously it does this several times, many times in a second. So what that allows us to do is it's going to give you a very, very realistic model of flight. That's why flying it, taking off, some of the kids are going to crash it. So don't feel, if you do this and you've not done it or if you've crashed, that there's a problem there. Okay? So give it a few minutes. It's going to take a little bit of time. You're going to probably find that the boys are going to pick it up a little bit faster than the girls because they tend to play more of the hand-eye coordinated video games. That's not always the case, but it's often the case. Older people seem to have a harder time with it than the younger folks. Now, let's go ahead and let's look at the plane itself from the outside. Pardon me. So let's go back over here. All right. You can use your arrow keys, and this is on page 4 of lesson 1. You can cycle through the airplane by hitting W, will give you the inside, and A. Don't worry about knowing that this very minute. That's what we have the worksheet for, and watch. You can rewatch this. All right. I'm using the arrow keys in the back to go left, right, above the plane, below the plane. Okay? Now, the next thing we're going to do is I'm going to go ahead and hit the // and you can even get the lift vectors on the airplane, which is pretty cool. And later on, we're going to show how to use that. All right. Now, let's go ahead and redo this one more time. Go sit back to quick flight setup. That's why I always like starting there. Click runway 8 because we're at Lowry, we're at the airplane, nothing changes. Have them go to use quick flight setup too if they've got to restart over, if they crash the airplane and the engine won't turn on, any of those things. Just use quick flight setup. Also, the kids have a tendency to say they're taking off. Say you're looking at the weight of the airplane and the takeoff distance. Well, the kids will take off and then they'll say, well, I have to crash the airplane to restart. No, they don't. They just need to go to quick flight setup. Okay? So, here we are again. We're going to go through those steps one more time. I'm going to hit pause. Notice when I click somewhere else, what happens is we got the brakes off. I've got the throttle in. So brakes off, throttle in, pause, the square is still up there. If I click outside this square sometimes, like it's not paused, I got to be careful because that square may or may not stay there. If it does go away, just click on that cursor and it'll come right back up. Again, I'm pushing the nose down a little bit. You're going to find out later why you would do that and take off. All right, getting up about 75. Pull it down just a little bit. And there we go. Go ahead, just practice that. Have the kids show it. They'll all get very excited about this. Okay? Now, the point of this lesson, remember, we're talking about potential and kinetic energy. And what we're going to be looking at on this airplane is at these 3 instruments again. And we're going to get the kids to draw the instruments in. If you can go to page 6 if you have the handout with you, and I'll try to describe it if you don't. You're going to have an airspeed on the 6th page. You go through the quick flight setup, which you've been practicing. Then it says, all right, go ahead and we're going to fly the airplane and final approach. So watch this. We're going to settings, quick flight setup. Now we're going to go with that 3 nautical miles final approach. Don't click on go to the airport. Click on 3 nautical miles, but then hit exit. Because you're not at the airport. You're right outside the airport. Now let's pause this. You're getting the kids to fly level flight. Now you can talk to them about the instruments again. You can say, well, what's your airspeed? And they should tell you something like, well, it's more than 80. What's the attitude indicator? It's half blue, it's half brown. That would indicate we're flying level. But let's just look on the airplane, and yeah, we're flying fairly level. And then look at our altimeter now. It's no longer at 2,000. It's not, for example, sorry, I'm choking there a little bit. It's not at 2,000. It's almost approaching at 3,000 now. So you're over 800 feet off the ground. What we're going to try to do is show the kids the difference about airspeed and altitude. So in this lesson, all you want the kids to do is mark on that. We have a diagram, a picture of the airspeed indicator. All you're going to do is draw a line there. You don't have to even write down a number on this first lesson. The altitude indicator, they can say, is it half blue, half brown? And the altimeter where it's pointed at. Okay? We're just drawing lines. Now, the next thing the kids are going to do, and I've kind of jumped the spot here. I haven't explained potential kinetic energy to you folks, because I figured most people have had it, but you would introduce that to the kids at this point or right about now then if you want to. And that is potential energy. This is the energy of storage. Just for expediency's sake, we'll say it this way. Kinetic energy is the energy of movement. And in an airplane, they're going to discover potential energy is altitude, movement is airspeed. And how do we control that? Well, the first thing they're going to do is they're going to point their nose down, which is always very popular with the kids because they're about to crash the airplane, or at least they think they're going to. So we're going to hit pause and see how the square went away. I had to just click it to bring it back. I'm going to let it go down for about 3 seconds. Pause. Now it's a little bit shorter than that, but we're going to make sure everybody can see it. So I pointed the nose down. The kid's drawing what the airspeed is. Notice my airspeed is higher. The attitude indicator is more brown than blue. And my altimeter has gone from 3,000 feet now to 2,500 feet. So we've gained airspeed. We've lost altitude. So that's that trade-off, because one of the other things the kids we're trying to get them to discover is energy can't be created or destroyed. It simply changes forms. So they'll draw that line in. We're going to unpause it now and pull it back up. Try to keep pulling it up. Sorry if on the webinar it's not coming through quite as through. I'll just take my time. The plane's going up. It's going up. I'm trying not to stall it. Boom. Let's see what it looks like. Well, let me give it a little more up here. We're going to do it this way. Okay. Well, look what your airspeed's done now. You're now less than 50 knots. Your attitude indicator's showing all blue, and you've gained back up to 3,100 feet. So hopefully as your kids talk about that, you can ask them questions as, does the pilot want to go faster? Do you point the nose up or do you point the nose down? And clearly, they should be pointing their nose down. When you're flying fast and faster, is your kinetic energy going up or down? Well, the kinetic energy is going up, isn't it? But, what are you losing? Well, you're losing your potential energy. You're trading off kinetic for potential. In terms of energy, why does your plane slow down as you climb? In terms of that, you're trading kinetic energy for potential energy. And the kids usually get all these questions, by the way, no problems. You don't touch the throttle. Can you climb and fly faster? The answer is no. You'd have to, your doing both at the same time. You're adding both kinetic energy and potential energy into the system. So that would require energy. Then you can ask the kids, why is it dangerous to fly low and slow in an airplane? And basically, it's an energy deficit. You don't have enough to react. If you're too low and you have to climb a tree, you don't have enough kinetic energy to trade into potential energy. And if you get going too slow, the plane, we're going to learn about this in the future, is going to stall because there's not enough airflow over the wings, and you can't point the nose down to gain that airspeed. All right? We sometimes add extra questions, and we hope to add more and more of this. Flying higher, you're going to dive faster and faster. At some point, the airspeed will stop increasing. Why? And that's the concept of terminal velocity. When an object falls, drag decreases. When the drag force equals the downward force of gravity, the net force is zero, so it just can't go much. It's just going to start slowing down, and then it's going to be heat, and then it'll burn up. And honestly, that's kind of what happened on some of the shuttle disasters. The other thing you can talk to with an older group is really neat is fighter pilots talk all about energy management. And I'm working right now on getting energy management tables so we can explain it to older kids. It's very neat. They look at forcing the fight against your opponent. If you know you can climb faster than the other person, in other words, you can get to kinetic, you can trade kinetic energy out to potential energy much better. That's how you want to push the dogfight. Or if you know you can outturn your opponent. So they spend a lot of time actually in fighter school and flight school worrying about trade-offs between potential and kinetic energy. Okay. I'm going to try to do this. Unchat us all here. See if we have anybody have a question about lesson 1 before we go on to lesson 2. All right, let's try this. Let me see if I can input. This should unmute everybody. All right, I hear a lot of airplanes. All right. If anybody's got a question, go ahead and ask it. We better not mute. I was afraid of this with the airplanes. This is going to make it a problem. So, does anybody have a question here? Got a chat question? We'll try to help you out if we can. So give you a quick second here in case there's a little delay. Does anybody have a question on this first lesson? All right, Eric's got his hand raised. Eric, what is your question? Oh, there we go. How long is each lesson? Honestly, this lesson is showing in the video and stuff. We tried to shoot 1 lesson per class period. Now, there's a few lessons you're going to see that can be a little bit shorter or longer. It allows you real flexibility. Lessons, I'm thinking lessons 4 and 5, and then lesson 6 can be, can take 2 periods. But as a general rule, 1 lesson, 1 period. What's the best? Brian Bridges asked, what's the best class size in this? I would say, as long as you have 1 computer to 1 kid, you can go 2 kids to a computer, but I wouldn't do 3 or 4. You're going to have kids just sitting there then when that happens. I've seen it in classes up to 35 kids. The kids will get into this. And so discipline isn't any kind of problem. And what also, too, in case when's a good time to teach this, by the way, if you're going to have an after-school problem, great. And if you've got a STEM elective, great, you can be teaching in there. But this also lends itself well for energy and forces. We're lined up with the National Framework on Science and Engineering. They haven't come out with exact goals and objectives yet. When those come out, we'll make sure we meet those.